Hi guys, welcome back. Today we are going to learn about polynomial division, which I think is kind of fun. It's kind of like a puzzle and you just have to figure out like where things go in our area models. So we're going to start with this first example, kind of getting us into this whole thought process. So on your guys' homework that you should have done last night, you worked with area models. So things like this where you were taking this side times this side and then you were getting the middle and adding it all together. So now we're going to kind of use that skill and we're going to advance it to help us solve polynomials. So let's just start with this first one. So it says, using what you know about an area model, work with your team. Obviously, we're not doing that. You're going to just do it with me. To complete the puzzle below. To the left of the area model, write these expressions as the product equals the sum. The x terms need to sum to be 12. Okay, so they're going to tell us at the end, whenever I add all this together, my x's need to be 12. So that comes important in a minute here. Okay, so let's just start with these boxes right here. So we know that this is x, and we're trying to figure out what this has to be so that when I multiply x times that, I get 2x to the fourth. So I know this box above definitely needs a 2, and it definitely needs an x cubed, so that if I do 2 times x, or 2x cubed times x, I get 2x to the fourth. So that's how I figure out what that box is. Okay, so then next what we're going to do is, since we figured out what this 2x cubed is, I know I can multiply the -4 by it and get this box right here. So if I do 2x cubed times -4, this becomes -8x cubed. Okay, we'll just leave it. Okay, so now what else can we figure out in this puzzle? So we know, okay, so we know that this is 4. So let me do some more highlighting here. So we know this is -4. This box is 12x, and I think we can figure out what the box is up here to figure out what multiplies. So basically we're looking for what multiplies to -4 to give this to be 12x squared. So I need to multiply -4 by a -3 to get it to become a +12. So I know this definitely needs to be -3. And then I need an x squared, so this has to be an x squared up here as well. So now that I've got that box, I can now do this -3x times this x to get this box. So this would be -3x cubed. And then the one thing that is important is realizing that these diagonals are going to be the same. They're going to be common or like terms. So x cubed and x cubed, these guys are going to go together. Okay, so then we can also figure out, let me go to a different color. If this is 2x and this is x, I can figure out what this box is right here. So if I do -2x times x, this should become -2x squared. And then I can do the same thing here. -2x times -4 is going to give us this box, so this should be an 8x. And then they gave us the hint up here that my x's need to sum to be 12. Remember, my diagonals are like terms. That means these two boxes need to add up to be 12 x's. So if I already have 8, that means I need 4 more x's to go here. So that means this has to be 4x. And then I just continue the pattern. So if this is x, I know this box has to be a 4. So when I multiply, I get this 4x. And then 4 times -4, this should be -16. And so that's how you kind of work yourself through the puzzle. You know the sides have to multiply to give you the thing on the inside. And then your like term should always be diagonal each other. Okay, so then we're going to write this as a sum and a product. So the sum is all of this inside added together. And we're just going to add these diagonals together. So it starts with being 2x to the fourth minus 8x cubed. Well, I guess we can just add like terms together. So if this is -8x cubed and -3x cubed, -8 minus 3 is 8, 9, 10, 11, -11x cubed. And then if I have 12x squared minus 2x squared, this should be a plus 10x squared. And then 8x plus 4x should be plus 12x, and then minus 16. So that's going to be our sum. It's all of the things added together on this inside here. And the product is the outside, what you were really multiplying together. So you're really doing x minus 4 times this 2x cubed minus 3x squared minus 2x plus 4. And then the important thing is knowing that these are equivalent. So when I take this side times this side, I get this inside expression. So that means both of these two ways of writing this equation are equal to each other. So it is really important to know that the sum equals the product when we do it in this way. Okay, so we're going to do problem number 2. So this one's a little bit different. So this one says complete the area model below, writing these expressions as a product equals a sum, and then they give us the whole entire sum. So that means this entire thing needs to be what the inside of these white boxes become whenever we create this problem and whenever we're actually doing this multiplying. So the very first step is you take whatever your highest degree is here. So I take this 6x cubed and it goes in this top box. So this becomes 6x cubed. And then what we do is we do the same puzzle. So now we know that these two boxes have to multiply to give us a 6x cubed. So if I already have a 2x, I know that this has to be a 3 so that when I do 2 times 3, I get the 6. And then I have 1x, that means I need 2 more x's, so this has to be x squared. So then x squared times x gives me x cubed. Okay, so now we can continue and get this bottom box down here. So 5 times 3x squared, this becomes 15x squared. And then remember, diagonals are what give us our like terms. So now we need our x squareds to add up to be a positive 7x squared. So that means this box and this box have to add up to be positive 7x squared. So I already have 15. That means I need to take away 8 to end up at 7. So this has to be a negative 8x squared. So when I add these together, I get this expression. Okay, so then we just go again. So I know 2x times whatever this is right here is going to give me my 8x squared. So let's see, that would have to be a negative 4 and then an x. So if I do negative 4 times 2, I get negative 8, and then x times x gives me x squared. And then I can get this box by doing 5 times negative 4x, so this is negative 20x. And then we know diagonals are going to help us out here, so let me choose a different color. Let's do, I don't know, orange. So negative 20x plus whatever this box is has to add to be a negative 16x. So I'm already at negative 20, so to get to negative 16, that means I have to add 4x to it. So combining those gives me this negative 16. Okay, so then I can get this box up here. I know 2x times, this would just have to be a 2 to make it 4x, because 2 times 2 becomes 4, and then I already have my x. So then if I multiply 10 times 2, or sorry, 5 times 2, that becomes 10. And then we know that this worked nicely because we can see, let's see, I don't know. How about this one? That this was 10, and then my last number was also 10. So if these guys match up, that means that you did your multiplying right in this expression. Okay, so here's what we got. We did, your sum is now adding all these together. So 6x cubed, combine these, this would be plus 7x squared. Combine these, this would be minus 16x, and then plus 10. And then that's what we were trying to go for. We were trying to get the inside of the box to equal this because that's what they gave us. And then our product is this 2x plus 5 times what I got on top, 3x squared minus 4x plus 2. And then again, remember, it's important to know that these things are equal. So this expression is equal to this. So basically what we're doing is we're starting to factor it down and solve it. And what you guys really did right here is you actually divided. So here's what I want to write this as. So we said 2x plus 5 times this, oops, times this, 3x squared minus 4x plus 2, is equal to that sum. So equal to the 6x squared plus 7x squared, or 6x cubed, this should be cubed, minus 16x plus 10. So what you did in this expression is you said this times this gives us the inside. So when I multiply these two factors, I get this final answer right here. So now what we really just did is we just did division. So if I were to take this side of my expression and divide it by 2x plus 5, and take the other side of my expression and divide it by 2x plus 5, on this side, these cancel out. So I know that when I take this original sum and divide by this 2x plus 5, I get whatever I had on top of my box as an answer. So this is really doing division. When I do the sum divided by the number I had on the side of it, I'm getting the final answer. So you're taking, let's see, this sum and you're dividing by this, and then this top part is going to be your final answer. So your final answer to this division problem was 3x squared minus 4x plus 2. And since our number ended with 10, and that's what our sum ended with, that means it divided nicely and we didn't have a remainder. Okay? So then what happens if we do have a remainder? And don't worry guys, I'm going to go back and do more examples of this. This is just the beginning. So it says, what if it does not divide evenly? What if we have a remainder? Let's go back to long division of numbers, and how would we write the answer to 29 divided by 7? So if we're doing long division, and I don't know if this is how you guys learned, but you set it up like this. The top dog goes in the box, and then 7 goes on the outside. And then what you're looking for is how many times does 7 go into 29? Well, you know that 7 times 4 is 28. So I'm going to put a 4 on top, and then I would do 7 times 4 is 28, so I put 28 here. Then you subtract, and then you get 1. So that means that you have a remainder of 1. Now we write this in a different way. So if you do 29 divided by 7, we say that answer is 4 because it goes in 4 whole times, and then it is 1/7 left over. So you have your remainder over what you were dividing by. So this is how you write your final answer to division problems whenever they don't divide evenly. So let's do this with a polynomial. So let's say we made a mistake and copied the problem above incorrectly. And the equation was really supposed to be a plus 18 instead of a plus 10. So let's just go back and do this again. So this was 2x and this was plus 5 because that's what we're dividing by. It goes on this side. And then we're trying to get the inside to become this sum. So I know the highest number goes in this top box. So this becomes 6x cubed. And this is doing the same problem we just did. So this top box up here has to be a 3x squared because 2x times 3x squared becomes this. And then I can multiply this becomes 15x squared. Then I needed my x squareds to be 7x squared. So that means this has to be a minus 8x squared so that when I combine these two, I get 7x squared. This top box would have to be a negative 4x. This would be negative 20x. And then I need them to add to be negative 16. So this diagonal, you'd have to add 4 to it. So 4x. And then this box would have to be 2. And then this would be 10. Okay, so now the problem is these last numbers do not match. So I got a 10 instead of an 18. So it's saying the easiest way to do this is just to think about how do I make 10 become 18? What do I actually do to 10 to make it become the number 18? Well, all you do is you add 8. So whatever you have to do right there becomes your remainder. And then the way we write our answer is we say, okay, well, I did this originally and I got this as an answer. So I know when I have this first problem divided by 2x plus 5, I have this. So I know this becomes 3x squared minus 4x plus 2. But then I have that remainder of plus 8. So the way we wrote that up here is we took whatever our remainder was and we divided it by what we were dividing by. So then we're going to do the same thing down here. So our remainder is 8. So this becomes plus because it's a positive 8. Over, and then we were dividing by this 2x plus 5, so then that becomes our remainder, and then that's how we would write this answer. So whenever we do this division right here, and it doesn't divide nicely, we have the remainder, and that's how you guys write your remainder. Okay, I'm gonna do one more example of this, and then I'm gonna do a second video that kind of walks you through the 2 things that you're gonna see when you do this division, and then you guys are gonna do some practice. Okay, so here's the step that you guys take. So first thing you want to do is you want to create your area model. So on this left side over here, this has to be 3 rows long because this is an x minus 1. So I'm going to start by drawing 3 rows. And then I'm going to skip the top box, and then I'm going to write x minus 1 here. And then what you do is you take whatever this degree is and you draw 1 more column than that. So this is a degree 4, that means I need 5 columns. So this is 1, 2, 3, 4, 5. And then that's how you know how to get your area model. So columns equal degree plus 1. Okay, so then let's just walk through this process. So highest degree goes in this box. So this becomes x to the 4th. Then you do the puzzle. So what do I multiply x by to get x to the 4th? Well, this box up here has to be an x cubed so that I have 4 total x's. So now I can multiply this and get negative x squared or x cubed. And then remember your diagonals have to be your like terms. So I know these 2 diagonals have to be by x cubed. And I want my final answer to have negative 5x cubed. So I'm already at negative 1. That means I need to subtract 4 more x cubes to get that to be a total of negative 5. And then I just go through the puzzle. Okay, well, this has to be a negative 4 to get this to be a negative 4, and then I need 2 more x's. So this is going to be negative 4x squared. Okay, then I can multiply these 2 boxes. So this would become a positive 4x squared. And then let's do diagonals again. So you know these diagonals are going to be your x squareds, and I need my x squareds to be positive 10x squareds. So I'm already at 4, so that means I need 6 more. So this is going to be 6x squared. And then this box has to be a 6x. And then this box would have to be a negative 6x. Okay, diagonals again. So I know these are going to be my x's, and I need there to be negative 3x's. So I'm at negative 6. That means I'm going to subtract or add 3 x's to that, because -6 plus 3 gets me to -3. And then this top box up here has to be a 3. So when I do 3 times x, I get 3x. And then this has to be a -3. Now remember, we want to always check if these last numbers, let's see, I'm choosing a different color here. If these last numbers match, so the fact that this is a -3 and this is a -2 means that it did not divide evenly and we have a remainder. So all you think about is, what do I do to -3? So -3, what do I do to that to make it become a -2? Well, if I add 1 to -3, I get it to be a -2. So that means our remainder is +1. So then how we write our answers to these problems are always going to be this top up here. So this is always going to be the answer. So we'll say that this is equal to x cubed minus 4x squared plus 6x plus 3. And then remember how we write our remainder. It was a remainder of 1, so +1 means that's a plus. And then we do 1 over, and then we put the denominator as what we were dividing by. So we were dividing by x minus 1. And then this is going to be your guys' final answer to that problem. So I hope that makes a little sense. Please make sure you watch the second video that's going to be attached here, and I'm going to go through the 2 types of problems that you're going to see when you do this division. This is going to be really important skill for you guys to have for the next lessons that we do to finish up chapter 8, and also for the SAT. They like to throw a lot of these questions on the SAT. So I hope that made a little bit of sense, and then make sure you guys watch the second video coming up. Hope you guys are doing well.